In this exercise to finish up Chapter 4, we're going to play around with the Hello World program a little bit. So let's start a new project. We'll name it Chapter 4, Part 7. Click OK. So just to refresh your memory, the Hello World program simply wrote out Hello World to the console. And then we have a console read key. So what we want to do here is we want to modify the program so that we can change who we say hello to or what greeting we use. So to do that, we need variables. In this case, we need at least two string variables. So we'll call one of them greeting, and we'll call the other one who. So then once we have that, then we can say greeting equals hello, who equals world, and now our console write line statement will now become greeting plus who plus an exclamation point if we want it. So now if we run the program, we get the same result, but now we've done it with variables. And what that means is that it's very easy to change either one of them. So we can change the who and make it say hello friend. And we can change the greeting to hey instead of hello, for example. And by doing that, we increase the flexibility of our program tremendously. By using variables and being able to assign data to the variables, we set up our program so that we can modify it to include whoever we want to include in the who part and say whatever it is we want to say to them in the greeting part. Once we learn how to get input from the user via the keyboard, which we're going to learn in a future chapter, then we can completely generalize the program so that the user can enter whatever they want to enter at the time the program runs, rather than having to set the data with assignment statements before the program runs like we're doing here. So there wasn't really very much to this exercise. I just wanted to introduce you to the idea of variables and why they are so flexible and why they're so important to programming, because they really give us a flexibility that we don't have when we hard code. That's the term that we use, the console write line hello world. That's all it can say. By changing it to greeting plus who plus the exclamation point doesn't really matter there. Then we can put whatever we want to in the greeting and whatever we want in the variable who, and it just makes our program that much more useful. So that finishes up all I have to say about variables and data types for now. And we're ready to move on to the next chapter where we introduce the concepts of classes and objects. In this lesson, we're going to see how to assign data to variables. And there's two ways to do it. First of all, before we start, let me introduce you to a new concept, the concept of the comment. The comment is a piece of text that is not intended for the compiler to compile, but for the person reading the program to read. So when I put comments in a program, it's primarily so that someone who's reading my program will gain something from reading the comment. A comment begins with 2 forward slashes, and then that's followed by the comment itself. So a comment can go on a line on its own, or at the end of a line, so that when the compiler gets to the point where it sees the 2 double slashes, then it will just ignore the rest of what it sees. So now, moving on to assigning data to variables. One way to do it is using something called the assignment statement. That's what my comment indicates there. The way you do that is you first create a variable, or declare a variable. And then once you've declared the variable, then you assign it a value. To do that, we use the equal sign as the assignment operator. So the statement reads salary equals 20,000, but what it really says is assign the value 20,000 to the variable salary. So you'd read it, salary is assigned the value 20,000. In an assignment statement, we usually talk about the left-hand side and the right-hand side of the operator. On the left-hand side is always a variable, because that's the only thing we can assign data to. On the right-hand side can either be a piece of literal data, like a number, or an expression, such as 20,000 plus 2,000. What happens is, when the compiler reads this line, it evaluates the expression to get 22,000 and then assigns that value to salary. So the assignment statement allows us to put data into a variable. Another way to assign data to a variable is to declare it and assign it data in the same line. This is also known as an initialization statement. because assigning the value 1.02 is initializing the variable with a piece of data or with a value. So these are the two ways to assign data, either via an assignment statement or via an initialization statement. Let me do a couple more initialization statements just so you can get the feel for how they work. We'll do one more. You should use initialization statements when you know in advance or at the time you're declaring the variable what the value is going to be. Sometimes you don't know, so all you can do is declare the variable. But if you do know at the time you're declaring the variable, you might as well go ahead and assign it the data and save yourself an extra line of code. Remember that with all these statements, you have to have a semicolon at the end of the line. And if you don't, you'll have an error in your code. So to review, we assign data to a variable using an assignment statement or an initialization statement. Assignment statements are used when the variable has already been declared and you want to put some data into it. The initialization statement is used when you want to assign the variable some data at the time that you're declaring the variable. So those are the two primary ways to put data into variables: assignment statement and initialization statement. And with the end of this lesson brings the end of the chapter, and now we're ready to move on to an exercise where we're going to work with the Hello World program and change its contents using variables. In this lesson, we're going to learn how to declare variables. Before we can use a variable in a program, we have to declare it. A variable declaration includes the data type and the variable name. There are some optional things we can do, but we're going to stick just to the basic data type, variable name for a declaration. To create a declaration, which will often be in main, although it doesn't have to be, you provide the data type along with the variable name, followed by a semicolon. Remember that a semicolon represents the end of a statement. You'll notice that the compiler puts a green squiggly line under my variable name. I'll explain why it's doing that in just a moment. For now, don't worry about it. So there's an example of an int variable. Let's do a string variable. You see there's not really much difference between the two. Let's do a Boolean variable, and let's do a char variable. And that's all you really need to know about variable declarations, except for one thing. We can put multiple variables on the same line. So for example, I can create a list of variables. We'll call this rate and ratio. And I can have as many as I want. So I could have string, last name, first name, middle name, and have as many variables as I need as long as they're of the same data type. And that's really all there is to declaring a variable. It's quite simple. You simply provide the data type first, followed by the variable name. Now let me talk about the green squiggly line. Let me put my cursor here so you can see it. The variable salary is declared but never used. Strictly speaking, that's not an error but a warning, saying that you've declared this variable but you've never used it. Once we assign data to the variable, then the green squiggly line will go away. We won't do that in this lesson, so we're going to have to end the lesson with the green squiggly line being there. But trust me, we can make it go away, and we will. There is a way, which I'll show you in the next lesson, to declare a variable and assign it some data in the same line so that you never get the green squiggly line to start with. And like I said, we're going to talk about that in the next lesson where we talk about assigning data to variables. So that's coming up next. In this lesson, we're going to define what a variable is and how to create variable names. A variable is defined as a name for a memory location. Rather than reference a hexadecimal value where a piece of data is stored, we use a name that has some sort of meaning for the data that's stored there. We'll talk more about that in a moment. A variable always has a type associated with it. In other words, we're storing a piece of data in a variable, and that piece of data has a type. So the variable also has to have that type. And what that means is that when we create a variable of a certain type, we can only store data of that type in the variable. So in other words, if I create a string variable, then I can only store string data in that variable. Whereas if I create an int variable or integer variable, then I can only store an integer value in that variable. When I talk about data stored in a variable, I always call it the variable's value. And that's not a technical term, it's just a term I use. I just wanted you to see that so that when you hear me say that variable's value, I'm talking about the data that's stored in the variable. As for the naming rules, the first and most important rule is that a variable name must start with a letter. It cannot start with a number or any other character or symbol on the keyboard. It has to be a letter. After the initial letter, though, the variable name can contain other letters, numbers, and the underscore character. But notice I don't include symbols because symbols are not allowed in variable names. So you can't use the $sign or the % sign or any other symbol like that. Some examples of some legal variable names include salary, name3, where the number is at the end, and first underscore name and last name. Some examples of bad variable names include 3name, where the number is at the first of the variable, and first space name, where there's a space between first and name. The compiler would get confused by that and think that first is the variable and wouldn't know what to do with another variable name or another identifier coming right after it, because that's not part of the rules of the language. So you cannot use spaces, and you cannot begin a variable name with anything other than a letter. There's no real limit to the length of a variable name, but a variable name that's too short isn't very meaningful. For example, if I use A to store my name, that doesn't mean very much. How would I know that A has a name stored in it? Whereas if my variable was called name, then I know that a name is going to be there. And then variable names that are too long aren't practical in that you'll have to type the variable name several times in a program, and if it's more than 10, 15, 20 characters, you're going to get tired of typing it all the time. So you want a reasonably sized variable that has some meaning associated with the data that's stored there. And then finally, you should always start your variable names with a lowercase letter, because capitalizing the first letter is reserved for class names. And we'll get to that quite a bit later in the course, but for now, just understand that your variables should always begin with a lowercase letter. That's all the rules that we need to talk about for naming variables, so let's move on to the next lesson where we talk about how to declare a variable in a program. In this lesson, we're going to be looking at 3 other data types: the string, the Boolean, and the char. A string is 0 or more characters surrounded by double quotes. So for example, the phrase "hello world," when surrounded in double quotes, becomes a string. The string data type is a class, and what that means is that there's a large collection of methods or functions that we can use to manipulate strings. Things like reverse for reversing a string, length to return the number of characters in a string, and other types of functions that help us work with strings. We'll be seeing those quite a bit as we go through the course. The string length is limited primarily by your available memory. However, in a real working program, it's not practical to have a very long string, such as several hundred characters long. If you have strings that long, you probably need to store them as text files. When we talk about strings, we're really talking about things like names and addresses and data that's of a regular standard length. Strings can be combined with the plus sign or the plus operator in an operation called concatenation, so that 2 or more strings can be essentially glued together to form one string. For example, if we had a string hello and a second string world, and we put those together with the plus sign, hello plus world, we would get one string that was hello world. So concatenation is a very common operation performed with strings. Finally, the empty string, or 2 double quotes side by side without any spaces, is a legal string object and is used a lot of times to initialize a string variable. And we'll be talking about that later in the course. The Boolean data type is used to store true-false values. And in fact, the only values that a Boolean variable could have are true or false. Booleans are used in situations where we want to make a comparison. For example, salary greater than 100,000 will return either a true or false value depending on what's stored or what value is stored in salary. They're also used a lot in repetition, where we might have a loop while the balance is less than 10,000, then perform a set of statements over and over again. And again, the expression balance less than 10,000 will return either a true or false value depending on what piece of data is stored in balance. The char data type is any character in the keyboard surrounded by single quotes. So for example, we might have the lowercase a or uppercase A or a 1 surrounded in single quotes. Those are considered char data. Notice the difference between a char, which is a single quote, and a string, which uses double quotes. Char data are stored as ASCII values. If you're not familiar with ASCII, each character on the keyboard has an integer value that represents it internally. For example, the letter A has a value, the backspace key, the enter key, the space bar, all have integer values that are called the ASCII value for that character, and it's stored internally with an integer. If you're not familiar with ASCII, you might want to search for it on the internet, and you can see a table that describes what the different ASCII values are. That wraps up our discussion of string, Boolean, and char, and now we're ready to move to the next lesson where we're going to discuss the rules for creating and using variables, which are used to store data. The numeric data types handle all the numbers that will come into your C# program. The first of these numeric types are what are called the integral types, and the two main integral types that we'll work with are int and long. Int stands for integer, and long just stands for a long integer. Integer, or int, stores numbers in the range of -2 billion to +2 billion, leaving off some of the fractional parts there. A long stores a number in the range that you're looking at right there. I don't even know what number that is. But suffice it to say that for the purposes of this course at least, int will handle all of our integral data needs. There'll be no reason to use long in any of our programs. After int and long, then we have the floating point types, float and double. The float has a range or will hold a number 127 digits after the decimal point. That's a very precise number. Double, on the other hand, will store 1023 digits after decimal. So clearly float will handle all of our floating point needs, but for traditional reasons, we'll use double as the main floating point data type, not float. Another integral type is the byte. The byte stores a small number in the range of -128 to 127. We'll very rarely use this data type, if ever. There's also the short, which stores a number in the range of -32,768 to +32,767, and again, we'll almost never, if ever, use short in this course. And then finally, we have the char data type. The char stores alphabetical characters, as I talked about in the previous lesson, but they are stored as a numeric value, what's called the ASCII value of that character. Every symbol on the keyboard has an ASCII numeric representation, and internally that's how your programs store those characters or symbols or letters or numbers with an ASCII value. And the char actually stores the character as its ASCII value. So just keep that in mind when you're working with the char data type, and we will see some examples of char in this course. That wraps up our discussion of the numeric data types. In the next lesson, we're going to discuss some other data types. In this chapter, we're going to introduce you to the concepts of data types and variables. We're going to start this lesson talking about data types, primarily why we need them, what they do, and what they are. First of all, a data type defines the proper use of an identifier or an expression. An identifier is something like a variable or another keyword or command. An expression is like an arithmetic expression, 2 + 2, or in the example we saw earlier with the Hello World program, the string Hello World is also an expression. So a data type determines how an identifier or an expression can be used. Data types also determine what type of data can be stored in an identifier or written in an expression. I'm going to show you some examples of that in just a moment. And then finally, data types determine which types of operations can be performed on an identifier or expression. For example, we can't add a date to a number, and we can't perform addition on a string and a date. Those are examples of operations that are not allowed because of the mixing of data types. So an example of an expression that is allowed is the expression 12 + 2. This expression is allowed because we're taking two numeric data types, 12 and 2, and adding them together, which is allowed. On the other hand, 12 plus Mike is not allowed because it doesn't make sense to add 12 to a string. Now there is something called concatenation, where you glue two strings together. What we're talking about in this expression is trying to add a number to a string, and that's not allowed. Here's an example of concatenation that is allowed. Hello plus world will give you the string hello world. Here the addition sign is being used as a concatenation operator, and concatenation is allowed between two strings. In fact, that's part of what it really is. Another example of an expression that would be allowed if the data types are correct is salary times tax rate. Here we have two identifiers, salary and tax rate, which are being used as variables. And as long as salary and tax rate have both been declared as variables that store numbers, then this expression is allowed. Next, we're going to talk about the types of data types that you find in C#. First, you have numeric data types that store numbers such as 1000 and 3.14159. You have string or strings such as hello world or the name Mike. Characters, which are individual letters or numbers, which could also be characters or even symbols. You'll notice that the difference between a character and a string is a character is surrounded in single quotes and a string is surrounded in double quotes. Another example of a data type are Booleans, or the Boolean data type, and that allows true or false values. So data types are very important to programming languages, and in the next lesson we're going to talk about the first of those categories of data types, the numeric data type. In this chapter we introduce the important concepts of classes and objects. C# is an object-oriented programming, and to use the language to its fullest extent, you need to understand as much as possible about classes and objects. In this first lesson, we're going to present an overview of classes and objects and some definitions and explanations. And then in the rest of the chapter, we'll create some very simple classes as means of a demonstration. An object-oriented program is a collection of objects interacting with each other. We're already familiar with the idea of objects, because in the real world, everything we deal with is an object. The book that I'm looking at on my desk is an object. The people that I talk to every day are objects, although we don't like to refer to people as objects. But objects are everywhere. And by objectifying our programs, objectifying our computer programs, we bring a useful model into the programming process that helps us deal with complexity. An object encapsulates state, which is just data, and behavior, which include the operations or the things that an object does. Every object has some sort of state, what it's doing at the present time, its name, its age, things like that. And of course, objects have behaviors, things that they do. A car drives down the road, for example. That's all we do when we're creating objects. We create a single entity that includes both data and operations. A class defines an object's behavior and state. So the class is the definition of an object. A class can be defined or viewed as a user-defined type in a more technical sense. When we create a class, we're creating a type that we can use just like it's a built-in type like int or Boolean. Classes can be linked together using a hierarchical structure. This is already well known in the real world and it works in programming as well. An example might be we have a overall class called vehicle, and vehicles can be broken down into cars, bicycles, lawnmowers even, golf carts, things like that. So that's what I mean by a hierarchical structure. Classes higher up in the structure pass state and behavior to lower classes. So for example, when I define a vehicle has certain characteristics. And those characteristics can then be passed down to other types of vehicles, such as cars or a train, for example. An object-oriented program is a collection of objects where each object has its own set of responsibilities. So rather than try to mix everything up together, when we write an object-oriented program, we create objects that have strict sets of responsibilities. This way we know when something goes wrong in a program, we know where to look to find the error. The error is in the object that's responsible for that behavior. Objects form the basis of reusable software since an object can be used in any program that needs the object. That's another great benefit to object-oriented programming. Once we've created a class, then we can use that class and the objects that are based on it in any other program that we want to use. So that once I create, for example, an employee object, I can use it in a human resources program, I can use it in a payroll program, and I can use it in any other program that involves employees. That's a brief overview of classes and objects. The rest of this chapter will involve looking at how we actually create classes, and we'll begin that task in the next lesson. The best way to learn about classes is to actually see one be developed and used in a program. So that's what we're going to do in the next couple of lessons. We're going to create a simple class, a name class, that stores a person's first, middle, and last name, and then we'll provide some utility methods for working with a name. To create a class, you're going to have a separate definition in your program, and it has to go in a particular area of the program, and it has to go outside of the class program. Remember that Visual Studio automatically creates a class program. Our class has to go outside of that. It can either be at the top or the bottom. I'll put it at the top just so it's easier to see it. So a class definition always begins with the keyword class, followed by the name of the class. After that, we have an opening curly brace that indicates the beginning of the body of the class. The first thing we're going to do is declare the data members, or the variables for the class. In object-oriented terminology, we don't use variable. We call them data members or fields. There's several names you can use. And I'll probably either say field or data member. I'll try to use data member most of the time. A name consists of 3 parts: a first, a middle, and a last. So we're going to create those 3 members for our class, and that will be all we're going to keep track of in this simple class. Now you'll notice I put the keyword private in front of the data type. I'm going to explain more about why we use private later, but understand that the private keyword is what's called an access modifier. And what we're saying here is we're saying that first, middle, and last are private to the class definition, and only the class definition has access to the value stored in first, middle, and last. We'll say a lot more about private access as we go through this chapter. That's all we need for data. So the next thing we have to do before we can even use the class is we have to create what's called a constructor. The constructor allows us to create an object with our class. That process is called instantiation, and I'll be explaining that a lot more later on. So the constructor is always defined using the same name as the class. So I write public name, and that becomes the name of the constructor as well. Its arguments are going to be the 3 pieces that we need for a name, a first, middle, and last. So I'm going to use fname, mname, and lname for those 3 arguments. In the definition itself, what we're going to do is we're going to assign each argument to the piece of data that belongs to it. So fname is assigned to first. Oops, I made a mistake right here. Mname is assigned to middle, and lname is assigned to last. Let's close out all the other bodies. Also, that will keep those errors from triggering up as you saw them earlier. So here's our definition. Class name, our data members are first, middle, and last, and they are private and they're of type string. Then we have our constructor. Notice it's public because the user of the program, someone who wants to use the class, has to be able to access the constructor. And we're going to see how that works in just a moment. It's an example of what's called a method. In older terminology, that might be a function. But for object-oriented programs, or in an object-oriented programming language, we call that a method. The constructor method will take as many arguments as you need to initialize the data members. So we're going to have fname, mname, lname, 3 strings to initialize first, middle, and last. And that's what we do in the body right here. So then we close off the body with this closing curly brace, and then we close off the class definition. Now we're ready to use the class, so we're going to drop down to the class program and static void main. To declare an object of name type, we use name first, like it's a data type, and then we'll just use my name as the object name. Then an equal sign, followed by the keyword new. The keyword new indicates that we're about to call the constructor for this class. And then we can call the constructor with the 3 arguments. Notice that IntelliSense tells me what the arguments are for the class. One of the nice things about using Visual Studio. IntelliSense gives you as much help as it can to make it easy to work with the program. And that's all we have to do. Now, if we ran this program, we would have a name object instantiated called myName, and its data members would be Michael for first, Mason for middle, and McMillan for last. I'm not going to run this program because it doesn't really do anything. We're going to use this program again in the rest of the lessons, so we'll see how it runs later. But at least now we know how to create an object once we've defined the class, at least as far as its data members and a constructor goes. I have a lot more to say about constructors also, but we're going to save that for another lesson. That'll wrap up this lesson on data members and constructors. Now we're going to move to the next thing we need to know how to do with the class, and that's create a toString method so that we can display the data that we've assigned to the class object. After we've defined the data members and a constructor, the next logical thing to do is create a method that allows us to display the data in a class object. And there's a very standard way to do that, and that's using something called a toString method. In fact, it's so common that it's built into the language. I haven't mentioned this yet, but as an object-oriented language, C# has a built-in object called object, and all other objects inherit from the object class. In that class is a method called toString, and that toString method allows us to display whatever we want to out of a class object. Normally, it's the pieces of data stored in the data members. It doesn't have to be, but generally speaking, the toString method will display all the pieces of data in the data members. So let's look at how to implement that for our program. After the constructor, we begin the implementation of toString by writing public string, because that's the return type of the method, and then toString, and then open and close parentheses, followed by return, because it's going to return this data to the program. We're going to talk a lot more about implementing methods later in the course. For now, you're just going to have to kind of trust me on this. So we have a return first plus a space plus the middle plus space plus last to return the name in a form we can read. Now that we're finished with the definition, let's see if it works. And I'm just going to tell you right now, we're going to probably get an error, but I'm doing that on purpose. So we're going to create another object. Here we go. Then we want to write out the name using toString. So we call the method like so. MyName.toString. And you'll notice that, let me go back, IntelliSense should tell us what methods are available, even for an object that we've created ourselves. And toString is always available to any object because, like I said, it's part of the object class, and all objects inherit that method. So to call it correctly, we have to put empty parentheses at the end, like so. Now we'll put a read key to freeze the screen. So now let's compile it and run it and see what we get. And like I said, it worked, but there was a warning. So first of all, let's see what the method did. So it returned Michael Mason McMillan, which is exactly the data that we put in, as you can see right there. Let's put the cursor on it. And you can't read all of that, but it says that we need to override the keyword. The reason is that because toString is defined for the object class, when we use the method in one of our own classes, we are essentially changing the definition. And if we want to do that, we have to use a special keyword called override. Override says ignore the definition of toString that's in the object class and use the definition that's in the class you're implementing. So I override toString, and now it should work without the warning message or the green squiggly line. That should clear up as it just did. And you see it still returns the name. So we can do that with any name. Let's do one more name. Well, let's call it a name. And don't worry yet about that error under new name. We'll probably be able to clear that once we get, they say it cleared its own self. Ah, there's an error. I typed a colon instead of a semicolon, so let's change that. You'll notice that the editor always tries to anticipate errors, which is kind of annoying, but in the long run it's helpful because you'll see your errors way before the program runs most of the time. So now we have two names. Let's run the program, and you'll see that it displays both names. So toString is a standard method that most or all classes need to implement that allows us to return the state of an object, and that's just by returning whatever is stored in the data members of that object at the time the toString method is called. Now that we've seen how to display data, we need to look at ways to get data into and out of objects besides using just toString. toString works for displaying all the data or parts of it. But there are things called set and get methods which allow us to set the values of data members and get or return those. And we're going to look at how to implement those in the next lesson. Once we've defined the data members and the constructor and a method for displaying the data, toString, we need to create some get and set methods to allow us to set and return individual pieces of data from a class object. So I'll put a little comment here saying these are called get and set methods. Let's start out with a get method for returning, say, the last name. So here we're going to write public string, because string is the data type of the return value of the method, and we'll call this get last. All it does is return the last name. Let me scroll that up so you can see it a little bit better. So get last will return the last name only. We'll do one more. Return first. So get methods return pieces of data from a class object. Now let's look at some set methods. Set methods use a special keyword called void, and I'll explain what that means in just a minute. And so here we're simply setting the first name to the argument. So first is equal to fname. We use void because set first is not a value returning method. We're not returning anything from the method, we're using it to set a piece of data. So because it's not returning data, it has to be declared as void. Now you'll notice that the constructor method does not use void, but it's the only non-value returning method that won't be void. So let's do another one here. Like so. So there's set first and set last. Now we probably want to have one more set method called set name that sets all three pieces. Later in the course I'll show you how to create other types of constructors, including what's called a default constructor. Oh, I have lname twice. Let me go fix that before we move on. I'll show you how to create what's called a default constructor, where you set a class object to its default values, which in this case for first, middle, and last would be the empty string. So first equals fname, middle equals mname, and last equals lname. Now this is a good time to mention that in a real program, in a real world application, we would probably write some data validation code in here, making sure that these values weren't empty strings or numbers that were listed as strings, things that would make a name invalid. Now we don't really have time to show you that in this course. That's really not a beginning topic, it's more of an advanced user topic. Just be aware that there are data validation methods that you should be using in real-world programs. And later in the course, when we study classes in more detail, we'll talk about that some. Let's look very quickly at how to use these methods. So the first thing we need to do is create a new name. We'll just make up a silly name here, John Q. Public. Then we'll display it. Then we'll do a set first, change it like so. Then do another two strings, so let's just copy that code. We'll change his last to brown, do it again, and then we'll do a get first. Let's do it in backward order. Let's do get last, plus a comma space, plus my name dot get first. So we should see the name and last name, first name order with a comma. So let's compile and run that. And so there we see John Q. Public, and then John Q. Public with John spelled different. Then we changed the last name to Brown. Then we displayed Brown, comma John using get last and get first. So there's a demonstration of how those methods worked. So to summarize, a well-designed class should have a set of get and set methods defined for the class so that the user can work with individual pieces of the class as well as whole parts of it, such as with set name. These are all part of a well-designed class and should be included with every class that you create. Because set and get methods are so common, C# provides a special feature called properties for working with individual pieces of a class, and we're going to look at how properties work in the next lesson. In addition to, or instead of using get and set methods, you can also create what are called property methods. Property methods, or just properties, allow you to use assignment rather than argument passing as the means of setting individual parts of a class object. Let me show you what I'm talking about. If we want to create a property for the first name, we started off by writing public string first. Again, because we are going to return values for part of it. Then, in the body of the property, we create a get part, like so, and a set part, like so. Notice that for the right-hand side of the assignment statement, we use the keyword value. Now that will come into play when we actually set the value. I'm going to show you how that works right here. I'll erase it and put it back in. So I write my name dot first equals John, and that's calling the set part. So John is the value. That's what this keyword value stands for. And it has to be a string. That's because we set string as the return type for the property, and it will also bind that data type to the value keyword. So for example, if I try to set first to a number, I get an error. Cannot implicitly convert type int to string because it's expecting a string at this point. I can also return values using the property method. So right here where I had my name dot get first, I can now write first, like so. Let's compile this program and see if it works. So it works just the same as it did before, but now we're using a little bit different syntax to get and set a data member in the class. You're not required to use properties in C#, but most C# programmers do use properties either instead of or in addition to get and set methods. Get and set methods come from other object-oriented programming languages such as Java, and properties are more commonly found in the .NET languages such as C# and Visual Basic. I won't implement the properties for the other data members here. We're going to do that in one of the exercises. And so now we're ready to move to the next lesson where we talk about some utility methods that we can use with a name class. After you've added all the get, set methods and properties that you want, then you can go on to writing methods just to get things done with your class. So with the name class, one thing we might want to do is return the initials of the person who's named in the object. So we'll write a method for that. We'll call it getInitials. And we're going to have it return the first character of the first name. We do that by using a method called substring, plus the first character of the middle name, plus the first character of the last name. So let's test that method before we move to something else. So we call getInitials. Now let's compile and run. And there's JQP. So something else we might want to do is return the name in some other format than first, middle, last. So we might call this getLastFirst. So here we're going to return last plus a comma space plus first plus a space plus middle. So then we can come down here into our program. We'll do it two ways. We'll use toString and then we'll use getLastFirst. Okay, so let's compile and run that. And there's John Q public and public comma John Q. We might have put a period there, but since it's really the whole last name and John's just happens to be Q, we don't need the period. There's many other types of things we can do, but I just wanted to give you a feel for some examples of some utility methods that you can write for a class. Later in the course, when we study classes in more depth, we'll look at quite a few more methods that we can use, such as comparing two class objects together. That takes a special type of method to check for, and we'll look at those later in the course. But for now, we're going to move on to the exercises for this chapter. For this first exercise of the chapter, we're going to work on the name class some more and fill in some blanks that we left out during the regular part of the chapter. First thing we need to do is add get and set methods for the middle name. So this gives us a good chance to practice those. So we'll do our get middle first. So it simply returns the middle data member. Then we'll do our set. It takes a string argument and it sets the middle equal to mname. So now we have a full set of get and set methods for first, middle, and last. The other thing we need to do are add properties for last and middle. So we're going to do it above the first property. So we're going to do public string middle first. So we start off inside the block or inside the definition by doing the get part of that. Then we'll do the set. And so remember its middle is equal to value. We close off set and then close off the definition. Now we'll do last. So we return last in the get. And we set last equal to value in the set. Close off the definition. Look over our work. Make sure it looks like we did it correctly. And I believe we did. So there's get middle and set middle. So we can write a little bit of code to check that. So we'll just pick a name at random. Then we will display it. We'll just use the toString method. So let's change her middle name using the property. Just anything, doesn't matter. And so you see the difference. We have to use the parentheses in a method call, but with the property you don't, either setting the property or returning it. So you see how when I'm calling the property to return, I don't have to use the parentheses. And that's a little bit different than what we're used to with method calls. Let's do one more, and let's change her last name, and then let's return her name using the properties rather than the getters. All right, let's check it by compiling and running it. And everything looks good. So we added some methods, some property methods for last and middle, and getters and setters for the middle name also in this exercise, and saw that everything worked correctly. So now let's move to the next exercise where we're going to work on a different class, a date class. In this chapter, we're going to be talking about how to do arithmetic with C#. And in this particular lesson, we're going to start off kind of slowly by talking about the arithmetic operators. And we're going to do that via a couple of variables. We'll start out with int variables. We'll do num1 and num2. We better assign those variables values. So we'll do 24, 13. And I did that on purpose. I had one even number, one odd number for a reason. We'll see that in just a moment. So we'll start out here. The first operator is the addition operator, which is the plus sign. So the plus sign performs arithmetic. I should mention that the arithmetic operators are binary, which means that there has to be an operand on the left side and an operand on the right side. Let's go ahead and run that. Let me add a read key first. And we'll start debugging. And we get 37, as we expect. The next operator is subtraction, and that's the dash or the minus sign. Let's run again. And we get 11. So 24 minus 13 is 11. Next up is multiplication, which is the asterisk, or sometimes I call that the star because it's easier to say than asterisk. And 24 times 13 is 312. And then finally, we have division, which is the /, like so. Then when we run the program, that's why I made 13 an odd number, or num2 13 an odd. Notice that when you're working with integer values, you don't get a floating point result with division. So we lost some information there. And that can always be a problem, so you need to be careful about declaring your data types based on the type of operations you're going to be performing on them. Because with 24 divided by 13, that answer is not 1, of course. All we have to do here is change the data type to double, and then run again, and we'll see that we get 1.85 rounded off. And so then finally, the last operator we want to talk about in this lesson is the modulus operator. That's the percent sign. And that's for remainder arithmetic. We'll just stick with our two regular variables first. And we'll see that 24 divided by 13 leaves a remainder of 11. Now that may not mean much, and modulus doesn't get used all that often with numbers like that, but let me show you a situation where it does come in handy. 4 modulus 2 should give us a value of 0, as you see there. Let's do one more. 4 mod 3 will give us 1, but really what I wanted to show you was the operation before that. Anytime you perform modulus with 2 and the result is 0, that means that that number, the number you perform the modulus on, is an even number. So you can use modulus to determine if a number is even or odd. Any number mod 2 that has a result of 0 is an even number. Any odd number, for example, 3 mod 2, will come out 1, as you'll see right here, because there's a remainder of 1 when you divide 3 by 2. So to review, the arithmetic operators are the plus sign, the minus sign, the asterisk, the slash for division, and the percent sign for modulus. Those are not all of the operations you can perform in C#. Those are just the built-in operators. Later in the chapter, we'll look at using a class, the math class, to perform other operations such as square root and absolute value and operations like those. But those are the primary or the built-in arithmetic operators, and that wraps up this lesson on them. In the next lesson, we're going to talk about the order of precedence, because there is a particular order of precedence in how the operators are evaluated. And we're going to look at that in the next lesson. Take a look at the following program and try to figure out what will be displayed when number is written to the console, what the value of number is going to be when written to the console. You might think it's going to be 2 plus 3 is 5 times 4, 20 as the value that's displayed. But if we run the program, you see that the value is actually 14. The reason for that is because C# has an order of precedence for its arithmetic operators, such that multiplication occurs before addition. So the 3 times 4 sub-expression is evaluated first, and then that value is added to 2 to get 14. Multiplication, or the multiplicative operators, have a higher order of precedence than the additive operators. So multiplication, division, and exponentiation are performed before addition and subtraction. If you want to modify the order of operations in a formula, put a sub-expression in parentheses. And parentheses have a higher order of precedence than the multiplication or the multiplicative operators. So it will be performed first in each sub-expression in parentheses. So in this case, we will see the value is 20, because the 2 plus 3 operation is performed before the multiplication due to the parentheses. Remember that anytime you write a formula in C#, the compiler will get it correctly based on its rules of precedence. So if you need to break those rules, in other words, if you need addition to be performed before multiplication, and they're at the same level, then you need to put parentheses around that sub-expression that you want evaluated first. Otherwise, the compiler will follow its rules of precedence, and multiplicative operators are evaluated before additive operators. There's not much else to talk about in this lesson. We're going to play with formulas in the exercises, so you'll see an example of modifying the order of precedence. So it's probably time to move on to the next lesson, which is on some special operators for incrementing and adding values to variables. One of the things we have to do often in a computer program is increment or decrement a variable by 1. So for example, if we initialize number to 1 and want to increase its value to 2, we have to write number is equal to number plus 1. If we want to decrement it, we'll have to write number is equal to number minus 1. Well, you do that all the time when you're counting things in programs, like how many records are in a file, or how many occurrences of a letter are in a string. Because we do this so often, C# has a shortcut operator for performing both incrementing and decrementing, and that's the increment and decrement operators. Let's take a look at those. The increment operator is the plus plus operator, and you place it either before a variable to increment it by 1 or behind the variable to do the same thing. So this first example is called prefix form, and that example is called suffix form. And again, all that operator does is increment a variable by 1. To decrement a variable, we use minus minus. So minus minus number. To decrement by 1, or number minus minus performs the same thing. There are some differences between the prefix and postfix or suffix form of the operator, but we don't need to talk about the differences between prefix and suffix forms of increment and decrement in this lesson. We'll talk about it in a later chapter. But for now, just think that they do the same thing, because they do. They both increment or decrement a variable's value by 1. There are situations where you want to increase a variable's value by more than 1. And to do that, we have something called the composite operators. So for example, if I want to increase number's value by 2, I can write number plus equal to, which is the same thing as writing number is equal to number plus 2. But again, it's much shorter doing it with the composite assignment operator. And I can write number minus equal 3, which is the same thing as saying number is equal to number minus 3. Every arithmetic operator has a composite assignment operator associated with it. So there's some examples right there. I'm not going to show you modulus, but it works as well. These operators make your programming a little easier by saving you from having to type a variable's name more than once in a statement. There's nothing all that earth-shattering about the operators other than they save you a little bit of programming time. And as you begin writing longer and longer programs, you'll appreciate these shortcuts when you can have them. There's not much else to say about increment, decrement, or composite assignment, so let's move on to the next lesson where we're going to talk about constants, or variables whose values cannot change. In many of the programs that you write, you want an identifier to hold a value, but you don't want to be able to change that identifier's value. By definition, a variable's value can change. What we want is something whose value can't change, and that something is called a constant. Let me show you how to create one. You start off with the keyword const, C-O-N-S-T, followed by a data type, followed by the constant name, followed by the equal sign, and a value. So for example, if we want to create a constant pi, then we write it like so. Now, so I can clear out that warning message, let me write out its value. The interesting thing about constants is that once you set their value, you cannot change it. So if, for example, I decided to try to change pi's value to 3.2, I'll get an error message right off the bat stating that the left-hand side of an assignment must be a variable, property, or indexer, meaning that it cannot be a constant, which is what pi now is. Another interesting thing about constants is that you cannot just declare them. So for example, if I try to create a constant number, like so, I'm going to get an error message at the very end of the statement because a constant field requires a value to be provided. So if I'm going to declare a constant, I also have to assign a value at that time, which makes sense because its value can't change. So you can't declare a constant and then try to change its value later, because once again you're going against what a constant's definition is. You have to declare and initialize a constant in the same statement. The advantage to constants is that a programmer can look at the definition once and know what the value of that constant is going to be throughout the whole length of the program. It also keeps you from making mistakes, such as accidentally assigning a different value to the variable if you're using that instead of a constant. So constants are more of a programmer's convenience than a necessary tool. But most times when you have special values such as pi or some other value that's special to your program, then you will assign that as a constant. I should also mention very quickly that you can also create string constants as well as constants of any other data type. I was sticking to numbers in this lesson because that's what we're working with in this chapter. But I should just mention very briefly that we can use other data types with constants. There's not much else to say about constants, so let's go ahead and move on to the next lesson where we're going to talk about other functions to perform mathematics that aren't built into C# and we have to use a special math library to obtain them. Besides the standard arithmetic operators, there are other mathematics you can perform in C#, but to do them you need to utilize the math class. Let me first give you an overview of the math class. You can access the math class just by typing math in your C# program. And then if you'll hit the dot or the period, you'll get a list of all the different functions that are available in the class. So we have things like absolute value, some trig functions, find the floor of a value. I'm sure ceiling was up there. Yeah, there's ceiling right there. Logarithmic functions, maximum and minimum. There's a constant for pi you can use instead of creating your own as we did earlier. The pal function, a rounding function, more trig functions. So let's take a look at how those work, just a couple of them, just to give you an overview. We'll do square root first. We'll create a variable number and set its value to 9. To compute the square root, we'll type math.squareroot, SQRT, and then provide number as the argument, and it should compute the square root of number. So let's run it. And there's 3. If we want to compute the absolute value, change it to negative, and then math.abs. Gives us positive 9, so the absolute value of negative 9 is positive 9. We can also raise number to a power. So let's raise number to the 3rd power. And there's negative 729 because we didn't change it back to positive, so it's still negative 9, but that's fine. You get the idea. So that's how you use the math class. So anytime you need some advanced math beyond the standard arithmetic operators, you can always call the math class anytime you need it to perform any functions that it contains. In the exercises at the end of the chapter, we will look at some more uses of the math class. One of the things you have to be careful about when performing arithmetic in C# is working with mixed data types. For example, if I declare number to be a variable of integer type and assign it the value 1, then if I come around later and try to assign it the value 2.2, you'll see that I get an error message. And the error message reads, cannot implicitly convert type double to int. An implicit conversion exists. Now, what that means is that I can convert 2.2 to integer value. The problem is I'll lose some of the precision of the number. So more than likely that's not what I want to do. If I wanted to do that, I could type the following command, like so. Convert .to int 32, and then the number that I want to convert, 2.2. Now let's write the number out, just so we can see what it does. So let's compile and run the program here. And you see that I did lose some precision. It's 2. So while I can perform the explicit conversion using convert, I don't really want to do that unless I don't mind losing the precision of 2.2 to 2. Now, going the other way is not a problem. I get no error messages or anything other than the warning that I haven't used number yet. Because going from a narrow data type, integer, to a wider data type, floating point, there's an implicit conversion that's performed. So that now the actual value of number is 2.0, even though I only assigned it the literal value 2. So it's okay to go from integer to double. You just can't go from double to integer without losing precision. So always be careful about that. And I have one more thing to say about mixing data types. Be very careful with division. So for example, if I write int number equals 2 divided by 3, and then I write out the value of number, the result I'll get is 0, because I'm performing floating point arithmetic division on an integer value, and since all that's left is a fractional part, it can't be stored in integer, so it just prints out the value 0. And though I can't assign number a floating point value, I can perform what will end up being a floating point operation and assign that value to number, but it will again lose precision. It'll only be able to store the 0 part of the number and not the fractional part. So be very, very careful when you're performing mixed data type arithmetic. A lot of times it will backfire on you, and you should always be very careful and very explicit about the types of conversions that you're trying to perform. That wraps up this chapter on arithmetic operations, and so now we're going to move to the exercise where I'm going to show you how to convert several different types of formulas into C# code. In this exercise in the chapter, we're going to convert a few formulas into C# code. The formulas are up here in comments at the top of the program, or just under the using statements. We have x divided by y minus 3, 1 divided by x plus y, where the x plus y is in parentheses, then the square root of x to the 6th plus y to the 5th, and then the absolute value of x plus y. So let's get started. First thing we need to do is create a couple of variables, x and y, and we'll assign them arbitrary values here. X is equal to 25, y is equal to 12, and let's change it from int to double. Okay, there we go. So the first one, and we'll just put these in console write lines to make it easy to display the results. X divided by y minus 3. And that's all we have to do there. There's no parenthesization to have to perform, and we assume that the division is performed first, followed by the subtraction. In the second one, we do want to perform the addition first in the denominator of this statement, so we're going to write x plus y in parentheses. So these two are fairly simple. The next one is not that much harder, but we do have to know to use the math class to perform both of these. So in fact, let's create another variable z and assign that the value of this expression. So first we want to get the square root, so we call the math class followed by the square root function. Then we want the square root of x to the 6th plus y to the 5th. So first thing we're going to do is math.pow x to the 6th plus math.pow y to the 5th, and that whole expression is in parentheses because we want to do the addition and then perform the square root. So that's how it'll look. Math.pow x to the 6th plus math.pow y to the 5th in parentheses, then we take the square root of that and then we close it off. And we'll assign z again And then finally, the absolute value of x plus y, z is equal to math. And so we just get some arbitrary numbers there. You can see the results. I'll put them in the middle of the screen. Just for fun, let's change x to negative 25. Run it again. Okay, so it was negative 13. Now it'll be positive 13 for the absolute value. And then our numbers changed accordingly because we negated one of the numbers. All right, so that is how to convert formulas, or 4 examples of how to convert formulas into C# code. Once you get the hang of order of precedence, then it really is just a mechanical process to take a formula you have written down and convert it into C# code. You should be able to do that with relative ease with just a little bit of practice. That wraps up this chapter on arithmetic. Now we're going to move to a little simpler topic, and that's input and output, and work a little bit more with console write line and with learning how to get input from the keyboard, which we haven't done yet. And that's going to come up in the next chapter.